Hello, everyone.
Hey, Mohammed, how you doing?
Oh, pretty good. What were you saying?
Pretty good.
Uh, I was actually, since we started recording, let's wait a little bit. Let's get it started. Today is Monday, September 25th. We're meeting for the OCP PCIe extended connectivity. Um, on our agenda today is to discuss collaboration with NVMe, and we get an update on the PCI SIG and discuss what other enhancements we want to do for the OCP requirements document. So Sam, I'm on the board of directors of the NVMe committee, and I was part of a discussion on their marketing team during OCP, what they want to do. And one thing I suggested is that we collaborate around PCIe extended connectivity and optical PCI, and how that would impact NVMe in general. It's something I don't know if you guys have interest of being involved in, but that is something on my agenda to collaborate with them on, with the marketing team there for NVMe.
Is NVMe, um, do they have any promotional engagements, or is it purely through sponsored booth space and sponsored sessions?
It's sponsored sessions, sponsored uh, analyst discussions. Um, they have their marketing team um, continuing to boast the NVMe um, benefits and overall health in the industry, along with all the features, etc. And I consider this extended connectivity of PCIe as a big benefit for them, because right now, in order to get extended NVMe connectivity, you have to uh, go to NVMe over Fabric, which was their solution of doing it. And that means significant cost on the host and the device um, infrastructure. So, like, if you really think about um, a bunch of SSDs or HDDs or whatever storage media um, that are capable of millions of IOPS and lots of gigabyte per seconds, trying to achieve that with fabric level connectivity, it adds significant cost. But with, an extended optical PCIe connectivity, that really kind of changes the game for them in terms of connections.
I guess, how does that change the TCO of the transition for them then?
Well, it's all about, again, we're talking about OCP. It's all about OCP capex and opex, and if you have today, if you're connecting a box of SSDs today, you need a bunch of RNICs, and from NVIDIA or from whoever selling them, Chelsea or whatever, and then that adds cost. It adds power versus an optical PCIe interface connecting to a head node with multiple connections can save power and save capex. We're talking about $1,000 boards, cards that usually connect to convert to NVMe over fabrics. And add latency. So the overall simplifications with optical PCIe takes away that added latency of typically of a fabric, fabric devices on both ends and going through a switch, etc. is typically on average it adds a average about 10 microseconds. If we can remove that down to nanosecond level latencies, that's definitely an advantage. So they view it as,
you mentioned 10 microseconds. What kind of switch is it that takes 10 microseconds? I thought even the Ethernet switches, if you have a single stage, it will be about 500. And if it's like a PCIe switch, I believe those will be probably less than 100, right?
it's not the switch, it's the RNICs on both ends, right? The NVMe over TCP RNIC on both ends that have to do the protocol conversion, and NVMe, taking an NVMe packet and putting it in an Ethernet packet and doing the TCP checksums, and a whole bunch of stuff, right? So it adds about 5 microseconds on each end. I neglected to mention the additional 500 nanosecond of the switch. So I was just focused on the cards themselves that will add that latency.
But if you use some of these lower latency protocol, would those help? Or like if there's Rocky and a few other things?
Rocky helps, but their tail latency goes into a 30 microsecond level because of the collisions, and their tail latency are higher. NVMe over TCP gives you better overall latency, especially with iWarp, but because they deal with RDMA disruption in iWarp can actually be continued, whereas with Rocky you have to start over. So there are some differences, fundamental differences there, but overall the best you can shoot for in those fabrics with not for single packet, but for consistent average connection average is about 10 microsecond with either protocols.
So isn't there another OCP workstream that's doing NVMe HDD integration? I could be wrong, but I thought there was. I haven't attended myself, but
yeah. So I'm co-chairing that with Jason Adrian from Microsoft and Dave Landsman from WD, but that's not about HDD. It's about NVMe in general, right?
Okay.
Right, SSDs and rotational media, everything, right? But it has not been, their solution, the NVMe committee solution to extended connectivity was Ethernet, and that, the HPC guys used IB, for example, and they get better latency. They get closer to 2 microseconds, right? That's what NVIDIA is using. But if you really want to be even taking that further down, I think what this team has done is enable the extended connectivity with potentially copper and optical, and really driven by CXL, we tend to benefit NVMe as well.
Yeah, I guess I was going to ask, and I think I may have asked this in the beginning when you had the sort of roadmap slides, but do you view this as sort of the key enabler for NVMe OF to really realize it? Because on its own, maybe it wouldn't grasp the attention, but combined with the CXL applications, this becomes really opportunistic. Yeah,
really the opportunity here is that PCIe now is taking a significant role in its own environment as a fabric enablement, right? It's further, it's evolving from being a bus to being a fabric enabler for CXL, which conversely helps NVMe as well and broadens the market adoption of optical PCI significantly, right? If think about it this way, your market window for CXL is just starting. It's a sliver, right? But your market window within NVMe, if you started there, it's huge. It's already established. SSDs, mainly for SSDs, and connecting them to cluster within a cluster. That's what NVIDIA was showing us in the early meetings of this discussion. That's why NVIDIA joined this team from the beginning. Even though they have NVMe over Fabric, but some of their effort around GPU Direct would love to see lower latencies. And regardless of Mellanox and IB Fabric and all that, the technology purists want to reduce latency further in clusters, in GPU clusters, and GPU connections to SSDs is critical, and time of flight, is ideal world, right? Is time of flight of electrical signal. If you have to go through additional protocol conversions and stuff, that's all wasted time for those guys.
But maybe it makes sense to do some type of like webinar after OCP.
Yeah. So that's what I'm gonna do a write-up and do a video as as a member of the marketing team and the board of directors. I can help influence that and make a broader announcement and some analyst discussions and stuff. But just giving you a heads up that this effort is not really limited to PCIe. It is NVMe and CXL that matters for us. Right?
No, I think that's a good point to frame it that way.
Yeah.
I guess in terms of the very beginning of this, we had sort of presented some market sizing expectations. I think the NVMe portion was pretty well documented.
Yeah.
And potentially undisputed, because I think we had a lot of inputs from people in that area. But on the CXL side, I don't know, just looking at the estimates, it seems like it was way under projected. Do you sort of feel the same way?
I don't know. I tried to be at the time conservative because I don't know how, let me bring that up actually. Just, Zoom is different, I have to think about it. Share, okay. Should be easy. Where is it? Where's the share button on this?
It should be in the share screen, right in the middle of the bottom, big green arrow.
Show.
Or might be at the top if you have it in the drop down.
Share screen, here it is. Okay, so let me bring up the Chrome. Machine is slowing down every time they do an update. So this was kind of the analysis there. It was conservative. I think 100,000 memory pooling appliance per year reflects into 2 million units. So I don't know. I really don't know how to adjust that with confidence. I don't have that level of confidence that it
Well, I
would.
guess it just seems like the the way that we were just talking made it seem like the opportunity to jump onto the back of the optical PCIe, the CXL demand would enable NVMe to kind of get over the hump. But this data sort of suggests that NVMe was maybe 2/3 of the way there, and the CXL is just a small portion that maybe helps create better justification. But I don't know, it almost seems like the CXL, pooled memory maybe, but then if it's also sort of linking like a fabric of GPUs as well, this could be 10 times that maybe.
Yeah, I see your point. So I'm just thinking I wasn't aggressive enough. I looked at only memory pooling. And we can add here GPU clusters.
I mean, I guess the feedback that I've received recently is kind of like NVMe over Fabric has sort of been out there as a potential new technology, but doesn't seem to be a real threat for traditional HDD storage architectures. And I don't necessarily agree with that, but it seems like if we're saying, look, this is a 10 million cable per year opportunity that's going to happen, and NVMe is absolutely going to be a byproduct of that, then it becomes like it's going to be here. It's just a matter of when rather than if type of thing,
Correct.
Because I imagine there's going to be some, I think even very recently, OCP projects have supported tradition and contributions have supported traditional SAS SATA based HDD storage structures. And again, I wasn't totally familiar with exactly what the OCP HDD NVMe group was doing, but it seems like at some point that could be a new project as that extends to extended connectivity. Contributions might be coming in that realm, and we might see these SAS architectures sort of go by the wayside.
Yeah, I don't know why some of my arrows disappeared. And sacred.
I don't think, I know you presented it somewhat on, I don't remember if you presented this last year, but are you planning to use this slide in your deck?
I plan to do it at OCP, yes.
Yeah. Okay. No, I think it's a really good one. I know I've referenced it myself a number of times in discussions because I think it provides the context for why this effort's happening and why it's important. So.
I don't know, 100 cables per cluster, maybe even conservative, because GPU clusters are growing significantly, right? And today it's done with C6 or other things, and I think they're going to consolidate around CXL eventually.
Yeah, and I think one of the things we keep hitting on is latency. I think we're limited in the number of cables we can connect per cluster by physical reach and latency. So
Right.
enabling the support for optical cables is gonna, yeah, like you said, kind of grow that 100 plus.
Yeah. So let's just say 100K memory pooling appliances. Greater than 200K. Actually, maybe 100K GPU clusters. That should definitely drive this number up significantly. Maybe 5 or 6 million.
Yeah, I guess I always just kind of thought the second use case was bigger with almost an unknown ceiling, but certainly bigger
Yeah.
than NVMe today. So this, I think, captures that pretty well.
So I'll do the math and correct this. I think it's going to be 3 million here, 150, 50. Yeah, that it really adds up quickly, right? It just if this is 600 million, and this is already at 400, so that we're talking about $1 billion.
That's certainly something that'll draw eyes at the summit.
Yeah. And these numbers are extremely aggressive too for cost. So
So are you envisioning this group to sort of remain in existence as kind of we'll kind of keep tweaking that requirements document as maybe conversations happen within NVMe and within PCIe?
yeah, so the question is I got from CMAC is what's next for us? What will take us to 1.0? And he was suggesting, I don't know, I'm not very talkative about our CXL effort within Seagate because it's still very proprietary under NDA. But he was asking if we want to give, since he knows some of the stuff we're doing, if we want to open up and give an example memory pooling solution that we could actually share with OCP and open for OCP through this pathway and collaborate with the composable memory group at OCP to give them a hardware systems cabling vision of what that would look like, because it seems like the DCMHS group deviated from creating a true example design, and they went into a wider. They didn't want to specify all the details. So the question is, can we create a memory pooling appliance requirements example, use it as just like we used in the spec. We made some example connectivity and showed how things will cable up, and used example AECs being, we listed QSFP, DD as an option. And for DOC, we listed some, SN or MPO example. There's no reason why we can't just, show a system level view of what the system will look like. What a memory pooling appliance could look like. And use, for example, use QSFP-DD as an example of an extended solution, or OSFP-XD, either one. And just so I'm wondering if this team wants to continue to do this, if they have the will for us to continue to expand into that, and showing an example. So in this section, we would expand on it and show an example of a memory pooling appliance connecting with either AECs or AOCs.
I guess that's where things get a little gray in the OCP designation space. Like, we've been sort of operating as a open mutual
Workstream.
interest group to create a requirements document.
Yeah.
I think what, certainly what CMAC and I know others are looking for on the board would be just a contribution of a design spec or even a product spec. But I think what you're describing is more of just a base spec of how the technology it could be integrated, what the channels might look like on the switch appliance side, what the interconnect lengths would be across the front panel to wherever they need to go.
Right.
Without, but I think those, like the CMAC, maybe other board members realize that, like, without an end user, end customer, those documents become really hard to write. And we've seen that. I've seen that with other work streams, like the OAI is a great example.
Yeah.
Where you have this base specification and you're trying to make it into that reference, but without end implementer really driving it home with all the the devil's in the details. If they're not there kind of pushing those decisions, then it becomes a document that doesn't really provide enough reference for people to pick up and have confidence that it'll work.
Right. Now, as a work stream, we don't have CDAs. We don't have what do they call them? CLAs or yeah. So like I could open up our own design and start showing details of what our plan is and all that, but as an example, right? But then I'm putting too much out there, right? And I do like to have a CLA at that point so that we're protecting the company interest in that design. So that's really where it would be great if somebody who's already planning to open up their design but we may need to change our posture from being a work stream with everybody has access to everything to something closed like the composable memory, like right now has 12 members or whatever, 15 members, and it's a closed CLA based solution. So I will review that with CMAC again, see what his mindset is. Maybe he wanted me just to do an example hypothetical and put my experience in actually building something to have that shown as an example without disclosing details. But I don't know how. It's going to be tough to do that.
Yeah, it's certainly a lot of effort on your part to kind of go that direction. I would sort of think it might be better for this group as is to sort of remain open, continue to push this requirements document into the organizations that we had been discussing, need to sort of pick up the next step, and then maybe along the timeline of the regional summit, next spring, there might be enough motivation. It might be the right time to sort of transition to a different type of structure. I just feel like to do that now would just be a lot of work for yourself or anybody who else was wanting to kind of get involved. I'd certainly like to be involved. I just know that's a pretty big mountain to climb at this point.
It is, it becomes significant mechanical effort. I have to pull a mechanical resource so they can start giving me ideas and exact details, and I have to pull, SI people and get more robust specification, but it's no longer a requirements document only.
No, I think that's fair. I guess I was kind of interested to know like what you're usually at these things, you always have to have the call to action, at the summit. So I know Chris and I are, tangentially related to this topic. We were planning to promote the need to sort of take this requirements document into these other organizations like we have tried to do and sort of give feedback and bring things back to the group to refine the requirements.
Perfect.
I don't know if you saw, maybe even going further than that, but I thought that was probably as far as we could commit and confidently ask for at this point.
No, I agree. I think it more than that is unrealistic at this point. So we need to find time in our day job, aside from our day job, and document a true specification with CLAs, etc. So my answer is going to be, well, let's branch off soon, maybe next year or later this year after this OCP summit, and see if we can encourage after the presentation we're going to do at the summit, see if we can encourage others to join us. And now that we have momentum and SIG support and all the above, it's like, we need to have people bite and start asking us to give examples. I would love to have I'm sorry, I forgot his name. He presented a couple times for us from NVIDIA. He was attending every meeting before until we released the 0.7. I'll reach out to him during that OCP meeting or before the meeting and invite him to see if they want to help do an example architecture for NVMe. And then maybe we'll reach out to Meta and Microsoft, who are already active within the composable memory infrastructure group, and see if we can actually get them to ask us to define hardware and cabling architecture. Right now, they're talking about OS and connectivity is assumed. Well, we need to have a specification team linked to that group and not be a work stream, but be more of a working group to help protect some interests there.
I think that sounds good.
Yeah. Anything else we want to discuss today? I'm tempted to just rev it up to 1.0 at some point, since we haven't really heard any comments or disagreement or anything, and just make it public that we're contributing 1.0. You guys support me on that?
I think that's definitely the right move. We can do it before the summit, so you can kind of announce it that way. If not, I guess I'd say, like you were describing, try to use that momentum, bring in some maybe new voices, and then go to 1.0. But I would suggest if you can get it done before the summit, we do that. It's a much nicer message to promote, this is available to the public.
In my meeting to the incubation committee, which included everybody, right, I asked for feedback. If you guys feel like we did not properly represent your requirements that you haven't shared with us, please let us know, so that we can properly represent the OCP requirements. And everybody said, okay, we'll review again and give you feedback if we differ. Nobody came back with any changes. Everybody, I heard from Ross Stanford, from others, um, um, that they're all in agreement in the essence of what we put out there. So we were, the only feedback I have is that we were too generous in terms of power numbers. So I may have to ask you guys to help me adjust the optical power numbers. The electrical power is what it is with regards to retimers. Right, Ali? I think we put in like 1 watt per lane, per bidirectional lane. That was Richard's input, 1 to 1.2 watt.
Is that for Gen 5 or Gen 6?
It was for both.
1 watt.
1 to 1.2 watt we put in.
Is that just for the retimer, or is that for additional function?
The retimer.
Okay.
On each end, right? So it was each end PXRX active power. But the criticism I received was on the optical side, we also had 1 watt, and they said that's too generous. But at the time, to my defense, it was assuming a retimer solution versus a CDR or redriver.
Yeah. Well, I guess in terms of, because many of the, like for example, at least Ethernet CDR DSPs, they do have integrated drivers and even TIA. So if you have those functions integrated into the retimer, then the question is that what is left for the optic, really, because you're integrating some of the function of the optics into the chips.
Yeah.
So in that case, then the power allocated for the optics, then it would be excessive.
Yeah, but again, I was told that the optical solution should be lower than 1 watt, but that's realistic.
Yeah. I mean, for example, if you had, let's say, I don't know exactly how the implementation for some of these, Gen 6 would end up to be. But if, let's say, for example, like an Ethernet, 100 gig Ethernet, like an SR8 module, if you have an advanced DSP, really the only thing you have left there is the VCSEL power, which is very small. I think a VCSEL probably will not consume more than 15 milliwatt per channel. And potentially the TIA is integrated. There's really not much left for the optics in that case.
Yeah, but then what about the electrical portion of that?
Well, that's the, I would say at least in many of the, more advanced Ethernet implementation, the retimer integrates all the system interface and drives the optics, so that's all in one chip.
Okay.
So I guess that's where, might be worthwhile to kind of peel this onion and kind of put down some of the partition and the power, because I would expect that any reasonable implementation the people will try to do integration.
Yeah.
We are not going to have a retimer here and then another driver retimer to drive the optics. They're all going to be in one chip.
Yeah, that'd be crazy.
Yeah. So I think if you have a more of an integrated solution, potentially that one chip would probably account for 80% of the power. Now, if you go with some of the single mode with like silicon photonic and external laser sources, those will consume a little bit more. But I don't think it should be a watt, even that case.
Yeah, because at that point they're sending multi-lambda through that.
Yeah, right. Right.
Yeah. All right, let me poll some of the optics guys and see what they come back with as a refined number.
Right. Okay, thank you.
All right, well, if we don't have anything else to discuss, I'd call it a day. I will invite people again to the fact that we have a Zoom meeting now. I don't know if everybody is working from an old agenda calendar, so I should probably send it again. Did you guys receive an email from the main calendar?
Yes.
Okay,
Yep.
good.
I did.
Some people just made a copy and did not register correctly. I just see that the attendance level is reflecting that level. Usually I would imagine more people. CMAC had very strong interest in attending, but I don't know if he really knew they were using Zoom. I should have sent an earlier message. I'll do that next week. All right, sounds good. I'll talk to you guys later.
Thank you. Take care.
Thanks.